Hello everyone, my name is Lyubina and today I'm going to explain to you why we need a sustainable digitization. And I think after the presentation we will have some time for your questions. Briefly about me. I studied environmental sciences at the Leuphana University Lüneburg and then did my master's degree in sustainability, economics and management in Oldenburg. I am currently working as a sustainability consultant at Bearing Point, an IT consulting firm. Internally, I drive the Sustainability Agents initiative, and as CSR lead, I am the contract person for the Hamburg office. I am currently working in the field of green IT and digitization of environmental data. To begin, I would like to introduce to you David Attenborough. But who is he? He is a British wildlife filmmaker and naturalist. David Attenborough is best known for his award-winning nature documentaries. When he started his documentaries in the 1950s, television was just getting popular. This means he was able to see the entire technological development of digitization right from the start, and was part of it for his whole lifetime till now on. He also started Instagram at the age of 93 a few weeks ago. When he started his documentations, the world looked like the picture on the left. Today, we see the world like the picture on the right. Within the last 100 years, we, humans, have caused this development. In his last film, Alive on Our Planet, he draws attention to the dangerous effects of human activity. Climate change is not just a problem for nature and climate protectors. It's a general problem. It used to be known that you could only fell as many trees as you could grow back. Today, it has become a complex problem that can be found in all human fields. Today we know how much climate damage is caused invisibly, through digitization. The increasing digitization in all areas of the economy and society is resulting in all increasing need for processing power, which is also spurring the growth of the data center industry. In spite of further progress in efficiency, the electricity consumption of data centers increases markedly. The increasing prevalence of mobile internet devices, such as smartphones and tablets, as well as trends such as cloud computing, big data, and the increasing use of multimedia services by private consumers gave rise to a distinct increase in IT capacities in data centers. Let's begin with some numbers. 1. A year of use of one cell phone emits as much CO2 as 2 round-trip flights. 6.5. Internet communication technologies in the EU consume 6.5% of total electricity consumption in the EU and are responsible for 4% of worldwide emissions, 2% caused by data centers. Every search query on Google or email sent uses as much electricity as an energy-saving lamp per hour and causes up to 10 grams of CO2. 12. For 3/4 of all companies using cloud services, the fact that the data centers are operated in Germany is a must. The safe harbor ruling by the European Court of Justice, which declared the rules for transferring personal data between the US and the EU invalid, may give this trend a significant boost. In addition, operating their own data centers continues to be very important for companies in Germany as well. 93% of persons responsible for IT in companies consider operation of their own data centers important. Also, further efficiency gains were achieved in IT hardware and data center infrastructure. The electricity consumption of the data centers in Germany increased by 3% to 12 billion kilowatt hours. 22. Bitcoin and Co. are energy thieves. The electronic mining of digital currencies consumes as much energy as entire countries. The use of bitcoins causes about 22 megatons of carbon dioxide annually. 25. The number of virtual servers in data centers is increasing more strongly than the hardware stock. It increased to more than 3.5 million. Compared with other European countries, Germany has the largest data center market with a share of approximately 25% of European data center capacity, followed by the United Kingdom and France. Taken together, these three countries currently provide more than 60% of European data center capacity. 250. An autonomously driving car produces a data volume of approximately 250 gigabyte per hour. 287. Data centers worldwide consume 287 terawatt-hours per year, and these are only examples. There are many more connections that we cannot measure yet. So, what do we have to expect for the evolution of digitization, for example, in 2025 and beyond? When we look at the big data, 45% of the world's data will be stored in publicly accessible cloud environments. But what about the cost? Expenditures for the IT hardware in data centers is increasing by 3.5% to 7.2 billion euros. The growth in turnover of IT hardware is supported in particular by the investments in storage hardware, where expenditures increased by more than 6%. The investments in modernization and new construction of data center infrastructure increases by 10% to approximately 900 million euros. Data centers. Increasing energy consumption by data centers is to be expected. If the current trends in IT usage continue, German data centers' energy consumption will increase further and reach more than 16 billion kilowatt-hours in 2025. Besides the servers, the storage systems consume the largest amounts of electricity in the data centers. The amount of IT equipment in German data centers increased markedly overall. The number of physical servers increased to nearly 2 million, a plus of 6%. This requires a lot of electricity, which is completely converted into heat. Every watt of electricity that goes in comes out as 1 watt of heat, and the computer chips produce more heat than the electric stove at home at the highest level. In such a data center, there are hundreds of thousands of disks right next to each other. The energy requirement is correspondingly high. 10% of the world's electricity is produced for the internet alone. For Germany, that means 33 million tons of CO2 per year. Trend ascending. When we try to analyze people's behavior regarding use of digital devices, we see some rebound effects. Streaming films, watching YouTube, that needs enormous infrastructure in the background and a lot of energy. About 10% of the electricity produced around the world is used to operate the internet. This requires ever higher computing power and thus more electricity, an enormous burden on the climate. Actually, that was the hope. Digitalization should reduce resource consumption. Paper would be not needed anymore. Business trips would be replaced by video conferences, according to the examples. So far, however, the opposite has occurred. You can shop quickly and cheaply on the internet, and a digital conference via smartphone produces a lot of emissions. In addition, digitalization itself consumes enormous amounts of energy. Almost 8% of global CO2 emissions will be due to digital services in 2025, which have a short lifespan because people like to buy a new smartphone each year. Rebound effects are wiping out progress in climate protection in many areas. In the case of streaming services, this becomes very clear. The computers are becoming more and more efficient, so they consume less power. The technology industry uses this argument to say, look here, we are becoming more and more ecological. But that is often not true, because at the same time the resolution in which videos are streamed is constantly increasing, so you need significantly more computing power again. In the end, the power consumption is often higher than before. According to a new study, global energy consumption for the production and use of electronic devices and the necessary infrastructure, especially servers and networks, is increasing by 9% annually. From this, we follow the fully digital world is not the solution to the climate crisis. When we talk about crisis, we also have to consider the international dependencies between countries, and in this case, the digital dependencies. Experts say the digital overconsumption is not a global phenomenon. It is caused by the rich countries. This goes hand in hand with the human rights violations, with severe environmental pollution, especially in the countries of the global south. We manufacture here in the global north electronic waste, which is then mostly shipped back to the global south. Not to forget the global warming, which has worldwide consequences through the digitally caused emissions. We have never been so dependent on the functionality of our mobile and landline network as we are today. The spread of the COVID-19 virus has moved most of the office goers their daily work to home. How comfortable this setup remains to be seen. But even the most professionally equipped home office is of no use if the image at the conference stops or files on SharePoint do not synchronize. Often this is not the case because the choice is made deliberately on the cheaper product, but because the connection with a higher bandwidth is simply not available at your own location. Digitization and bandwidth go hand in hand. In a recently published study on behalf of the Family Business Foundation was mentioned that 90% of the nearly 2,500 companies surveyed consider expanding their digital infrastructure to be suitable or very suitable for making the economy more resilient in times of crisis. New business models only emerge when data lines are fast and can be used in their full complexity. Crisis-proof, innovative services are not nice-to-haves, but form the basis of our future success. As the fourth largest economy in the world, the demands in Germany are high. According to the registration statistics, the share of fully electronic vehicles and plug-in hybrids in Germany was already 15% of all new registrations in September this year. Electric mobility, in particular, could benefit from a 5G expansion and thus reduce CO2 emissions. These are a few scenarios for the year 2045 from a city perspective, some more likely and some less likely to happen. Autonomous vehicles could play a major role in urban mobility and can become increasingly important. This means that everyone can move around independently without having a driving license. There will be no more new registrations of combustion engines. Ownership will be almost insignificant. Means of transport are permanently shared. Thanks to the widespread adoption of new technology and the availability of stable network, 5G, vehicles may be interconnected and communicate via internet. This could help to avoid traffic accidents and congestion. Goods and delivery traffic could take place 24/7, as most delivery vehicles can drive autonomously. The majority of German households produce their own electricity via solar panels. And here some scenarios for the year 2045 from a rural area perspective. Alternative drive systems, for example electric mobility or fuel cells, could also become established in rural areas. Transport vehicles could be shared and carpools formed. Agriculture could be largely autonomous, as commercial vehicles can be smart and networked. In rural areas, goods may be delivered directly to your home by drone. More people could switch from individual to public transport. E-mobility could become so widespread that short distances are covered by e-bikes. So, we see in the case of mobility, digitization is an opportunity. In order to improve mobility without causing additional air pollution and CO2 emissions, transport systems must be holistic and integrated. For example, when means of transport are shared or the flow of traffic becomes more efficient. Such an approach requires land use planning that shortens distances and travel times as much as possible. Compact cities in which walking and cycling are possible and the use of public transport is also attractively priced, also called as 15-minute cities. We see the opportunities from digitization and its dark sides. On the one hand, we have the opportunity to save resources and make public life easier, to share knowledge and especially in times of Corona to bring people closer. On the other hand, we have the environmental damage caused by digitization in form of exhausted energy resources and emissions that, with the internet and data growth, assume infinite dimensions that are invisible. That is why it is more important to think about sustainability in digitization now and not tomorrow. Here are a few examples of how we can support sustainable digitization. Green data centers means the association of digitization and climate protection. Mountains and lakes. That's what all Austrian tourists know. But water power can also sustainably power data centers. But these are not the only challenges. Ultimately, it's the handling of all types of resources that define sustainable digitization. The fight against climate change is an issue on the urgency of which there is an unprecedented consensus from a scientific point of view. In economic terms, however, the matter is more complicated. One of the crucial questions here is how can digitization with its enormous energy consumption and the fight against climate change be reconciled? The answer is as simple in theory as it is complex in practice. There is a need for CO2 neutral solutions that are both efficient and absolutely reliable. Supplying data centers, which play a central role in the database digital revolution, with electricity entirely from renewable energies is by no means impossible. However, in order to remain competitive from an economic point of view, some basis infrastructure requirements must be met. Location advantages plus the latest technological developments, regions with a corresponding share of hydropower in the energy mix have an absolute advantage here. The reason for this is the stability of the supply by hydropower, which unlike wind and solar energy does not depend on the respective weather conditions. At the same time, water is also the solution for one of the biggest energy and cost guzzlers in a data center, the cooling. The problem of energy storage is the event of insufficient energy generation. Does not apply to the use of hydropower. Since possible failures can still cause enormous economic damage, it must be ensured that the power supply is so reliable that non-stop operation is always possible. Innovative battery solutions, also for high performance requirements, offer a remedy here. Innovative architecture is also a new way of thinking about energy generation and management when building a data center right from the start. Cooperation with local energy operators for the use of waste heat complements the sensible use of resources. This applies not only to hyperscalers but also to small data centers. In order to improve the carbon footprint, everyone, for example politicians, cities and municipalities, must work together. It also makes sense to approach energy suppliers, research units and universities that have innovative ideas, for example when it comes to controlling with artificial intelligence, as the example of the Horizon 22 project Reuse Heat. The EU calculates using data center waste heat is not a question of conscience, but a necessity. Connection to data highway is a success factor, but even the combination of a location that is easy to cool with a sustainable energy supply is not enough to build an ecologically and economically attractive center. The connection to state-of-the-art fiber optic networks, which are also able to cope with the ever-increasing flow of data, is not only a requirement that data center operators must meet, but also in terms of the environment. Since short, direct data paths without diversion around half the globe save considerable resources. Digitization offers enormous opportunities for our society, prosperity, justice, environment protection, but if it is not properly controlled, it can also be an enormous fire accelerator because it uses a lot of energy. Accordingly, what we do, how we do it, and when we do it will lead to what we'll see next. Thank you so much for your attention.